So we use the Instron machine, this type of machine, for measuring mechanical properties of materials. This machine is loaded with different cell loads, which are these parts here that can easily come off, and I'll show you how. And then we attach several tools to then perform our experiments. The machine is connected to the computer, and the software is called the Blue Hill 3. So to run the machine, first of all you turn it on from here, the back. Once it's on, the machine will move unless we log in the Blue Hill software. There isn't any password anyway for the Blue Hill software. So now that you hear this sound, that means the machine is ready to be used. So we can control the machine with these two buttons to go up and down, and define position of the load with this other. So we can go up, so we can go down. We control finely with this. Yeah. So the first thing you need to do once you decide to do an experiment is to choose which cell load to use for your experiments. These are static load cells. For example, this one, which is in use now, is at 30k Newton. But then we have all sorts of other load cells here for samples that need, for example, less load or higher load. If you need a different cell load compared to the one which is installed, then we need to remove it. So there are, I'll show you can see, yeah. So there are 3 screws that we need to remove. Make sure you don't lose the screw, otherwise we don't know how to screw it back in position. Now we have to remove the attachment of the cell load from here. And now we can take the cell load. Okay. Yeah, so once you have chosen your the right load cells for your experiments, you have to put it back in position with the 3 screw in place. And you tighten it with a screwdriver. Okay, and we need to connect the load cells to these transducers here on the load, under what is written load. Okay. Now, based on the experiments you need to run, then there are different attachments that goes under this machine. So you will need to talk. You need to decide before you run your experiments which are the ones required. So again, we slide the same bar, another bar inside, and we lock in position so it doesn't move. And then so for the purpose of this demonstration, we'll use 3 attachments which are connected to the cell load through this attachment on the top. Based on your experiment, you will use different attachments. This is not that stable. So. Okay. So we open our software, Bluewheel 3. Okay, so the first thing we do, once the cell load is in place, we click on this button here, Load Transducer Settings, and then we click on Calibrate. So verify that no specimen is installed and the grips or fixtures are not touching with each other, which are these. Yeah, no specimen has to be in place. So you click OK. And what it's doing is basically calibrating the load cells at the moment. And you have to do this every time you change your cell load. And I suggest you do every time you do a set of experiments. Because you don't know if the person before you has done it. So now it's calibrated it, and we click done. The second thing that we have to look at is the extension of our machine. We have to set the extension here, right? So if I click on this button, extension settings, and then I click 0, the machine 0 this position. That means that this position now for the machine is 0, and if I go down or up, that is going to count from 0, right? So we want to place the 0 position where you want, after your experiment, you want the machine to go back. Yeah, if during the experiments the load goes down, and after your experiment you want the machines to go back in the same position, you place, for example, this position to be 0. So every time the experiment stops, the machine goes back in this position. Yeah, so I decided this is the position where I want to 0 the machine. So every time I complete my experiments, the machine goes up to this height, this level. Okay, so I 0 again here. I go back in this tab, click extension, put 0. This goes to 0, and I click done. Right. The second thing we need to decide is where to create a lower limit, because these two parts has to never touch each other. So we have to make sure that even if the sample crashes under the force, the machine will never get in touch with the bottom part. So we use this part, yellow portion for that. So we push down our load. For example, this is the minimum position I want to reach. I don't want the machine to go lower than that. So then I push this up and I screw it in place. So when the machine touches this point, it's going to stop. Okay, before you run your experiments, you need to create a method. So you click on this tab, method. And in create method, you can choose different methods already available there. For example, we choose compression method and click next on the right. So on the left hand side we have different tabs, which are basically the parameters that we need to use for the method, to set up the method. You need to go through all of them and fill in what is necessary. For example, if you need a sample description, not all of them are needed for the running of the experiments, but some of them are. Specimen properties, here you're going to put your specimen label, for example AT test 1, and you can choose the geometry. You can tell the machine, the software, which is the geometry of your the sample you're testing, if it's rectangular or circular, for example. and you can choose the diameter and the height. For example, usually I'm running 4mm diameter and 6mm in height cylinders. Then we need to choose, okay, let me get this. Oh, these are already default. So as defaults, the physical measurements the machine is going to get for you are these highlighted in the second, on the right portion, the right section, which are time, extension, load, strain, compressive extension, and compressive stress. If you want other measurements, then you can choose between these, for example, torque or other virtual measurements. If you require specific calculation, there are already available calculation in the software. For example, modulus. If you want to calculate the modulus, you just highlight the modulus and press the arrow to move the modulus on the other side. You can also change the calculation of the modulus, for example, by clicking the tab with the calculator. And here in the domain you can actually enter your calculation. Once you've done, you click OK. And you can add also other type of calculation, for example, peak, maximum and minimum, and etc. Depends on your experiment. Under test control, you can decide how you're going to start your experiment, or you're going to end your test, for example. These are all things, for example, you start with the start button, pretty easy. During your test, you need to decide which is the rate of the rate at which the machine is going to move, which is the extension. So you have to put in a value. We put 1 millimeter per minute, but this depends on your experiments, so you can change that. So the console is basically this part of the screen, which is always visible. It tells you extension and load in this case, as you can see. But you can have also, for example, compressive strain available here, and during your experiment you can have all these tabs ready there for you to read. So in the results tab, we click on it, so we can basically choose which are the results they will be available in our results table. For example, specimen label, you can choose. We can have, again, rate if you want. If you want to have, you can choose if you want to have a minimum and standard deviation, or a maximum, or coefficient of variation, everything like that. Okay, so in the raw data, then you can choose columns and format of your raw data. So this is how the data are going to be displayed after you run your experiments. So for example, we choose to show extension, load and time. If you want, for example, also compressive strength, you just add it and it comes up in your table. So under the export tab, you have to define a default location for your to save all your files. Okay, so we browse and you choose your location from OS, disk, C, users, public, and we put them in public documents under Instron Blue Hill output. If you don't have a folder, you can create a folder at this point. I put under my folder in test. Yeah, and you can add in this case a sample file name for the set of experiment you're running at this point. Every time you decide to run a different sample, every time you decide to run a different sample with a different file name, for example, you need to change this file name here, otherwise it's gonna go every time under the same file name. Yeah. You can decide to create your test with a property test sequence. If you want to run as a property test sequence, basically it's just the way the machine guides you to do step by step to run your experiments. You just click on this, and these are the all the steps, and you can choose, for example, to run all the steps or to run just for the machine to guide just a specific sequence of the test before you start your experiments or before you install your specimens and things like that. Once you've done you fill in all these parts of the method, you can save and close. It's going to go under templates, and you give a name and you save it. Now if we go back in the main page of Blue Hill, if we click test, I will find the method created under the method name here, and I'll double click. Now you choose your sample name, for example test 1, or you can give a different name to your sample. This is the location where your files are going to be saved in your output folder under your name, and this is your method that you choose, the compression method. Click next. So this is my prompted sequence. So the machine is telling me to enter following values before the start of the samples. I didn't actually enter this, so it's not coming. Okay, so I'll show you now how to run a compression test. I have already created my method, so I click test. Now go under compression test. This is my own method, Alessia. I need to name my new sample, so I have basically created cylindrical samples which are immersed in a trace buffer solution for different points, and I want to measure the compressive strength after immersion. So I will record the sample name here. The location where the files are going to be saved is under our output, Alessia, in my folder, and this is a compression method. So I can click next. Now, I created my method with some as a prompted sequence. So the machine is telling me to enter following values before the start of the samples, number of specimens in each sample. So I'm running 4 samples at the moment, so I have entered 4, and then I go click next. Okay, the machine is telling me to enter other values before each specimen is tested, which are the specimen label, which I need to change. Every time you run a new test, you have to change your specimen label because it's saved as the last specimen label you run. And the height and the diameter of my experiment. For this, I will measure I'll measure the diameter and height of the specimen with the micrometer. You need that if you want the machine, for example, to convert your force in megapascal, where is needed the volume of the sample. So you need to know height and diameter. So I just measure height and diameter. Okay. Okay, once you have filled in all these values, you click next, and the machine tells you to install the specimen. So you make sure the specimen is properly installed. It tells you to switch on the specimen protect, which is on the console here, and basically if you switch it on, allows you, once your sample is loaded, to do not crash the sample, right? So we load the samples. I'm using filter paper under my sample just to create wet filter paper to make sure that the sample is connected with the machine. So I'll put at the bottom. The top, and then I'll load my sample. Yeah. Okay, now I need to lower the machine at the level of the sample without just flash the sample. And I can fine control using this wheel. So then we can go back to our software, and basically I can press the start button, which is on the right side. So this is our workspace. We're gonna have basically here our specimen label, the maximum load in Newton, compressive extension, a maximum load, and compressive stress, a maximum load, which is in megapascal. Now it's running the first set of sample, and the graph I have on the left the load, and then on the x-axis the extension in millimeters. And these are my operator inputs, which I chose in my method, which is the rate at which the machine is running and the diameter of my sample. Now, if you see, depending on your experiment, you can stop your machine when basically the sample crashes. In this way, the sample is crashing now, and I can see also from the sample there is fracturing. So I can stop the sample and return to my zero position, which we set before. Yeah. So my sample is fractured, and then I can collect it. Okay, if your sample fracture and fragments of the sample just splashed all the way, make sure you wear safety goggles and to clean the area after. Okay, so if you want to then run your second experiment, you click next and you go again in the same sequence. If you want to finish your sets of experiments and save all the data, you just click this tab, finish sample. The machine tells you that you can now finish the sample. Click this button to finish the sample and save the sample file. So you finish your sample and save it. It tells you, do you want to start another sample using the same test? You can choose yes or no. I'll choose no. Because you have changed your specimen label, the machine comes up saying that the test method has been changed. since you last saved it, so you can decide to save the changes or just keep as it was. That's it. You were gonna find your so on the I'll show you again. On the desktop there is an output shortcut which you can double click. You can find your folder. And this is my last sample that I run, my raw data. And these are the raw data. So we have my specimen label, time extension, load and compressive strength that you can upload then on Excel. I also save this one, which is basically the graph, if you want to save it, and the table with the values that we obtained before. And this is a PDF, so you can print it. No, you can't print it. Sorry, it's a PDF, so you can save it on your memory stick. And that's